Cá está.
Já posso ter passado?
Pode sim, tem maneiras para entrar e começar.
Já está aparecendo aqui também a aplicação.
Tá?
Should I go for it? Ready? All right. Good morning, everyone. My name is Marco Bravo. I'm with the University of Texas at Austin. Great pleasure to be here. Thanks, João, Miguel, for the kind invitation. And I'm here, so the challenge was to let you know about what we are doing with Portugal. And I think it relates in a lot of ways of what we're doing here in Julia, what you guys are doing individually. So bear with me for the next 10 to 12 minutes, please. So the UT Austin Portugal program is a long-standing collaboration between the Portuguese government through the National Science Foundation here, FCT, and the University of Texas. And it started a little bit more than 18 years ago. And it focuses on research, education, so training, research, exchanges, and innovation. So it's a big part of what we're doing. And just to give you a little bit of a background, we focus. So we're starting the fourth phase now in 2025. So we're ending the phase 3 and kind of merging to this next phase. And the research areas that we've been working on are over there. So advanced computing, space Earth interactions, that's kind of what you guys are doing. And I'm going to go into more detail into that in a second. Medical physics, which is, proton therapies and things like that for cancer and all that stuff. Then nanotechnologies, and then technology innovation and entrepreneurship. Those are kind of the areas. And there are, there are several output metrics that we capture every year. I'm just going to highlight a couple just from some examples from 2023. It's a lot of the things we do is collaborative research between Portuguese researchers or researchers based in Portugal. They don't have to be Portuguese, but they have to be in Portuguese institutions, and researchers at UT Austin and MD Anderson as well in medical physics. And most of the output is in joint research, so joint papers, joint patents, things like that. But a very interesting and important metric is also on the innovation part. And let me give you a couple of recent impact examples. So this is Anne, and Anne is the co-founder of one of the startups, Portuguese startups, Sphere Ultrafast Photonics, that participated in the program. They very tiny when they started. They're still not huge, but they were definitely smaller, and they started with leading one of the research projects. That's how this company started, and Anne got to be awarded with the Nobel Prize for Physics. We were very lucky with that. I mean, We don't claim we have anything to do with it. We just claim that we were lucky to have Anne participate in one of the projects. So it was pretty awesome for us, very, very lucky of us. But it kind of, brought this huge spin on this company. Another good example is Paloma, and Paloma is the PI of one of the large projects we have. We have two types of research projects, what we call the strategic projects. Those are €1 million in Portugal, $1 million plus in the US, both combined for 3 years. And then we have smaller exploratory projects, 1-year projects that we also fund. And this was one of the big ones. And the great thing about it is this project leveraged other funding. So a ERC grant, which are pretty substantial for these researchers. And so the project really worked as a ground force for that. And so a 50K project with us leveraged, 1.5 million for the researcher, which is pretty impressive. Another one is this gentleman here, Portuguese, also PI with one of the projects that got the Pfizer Award in 2023. It's a big award in this area. And he got it because also of the work that he's been doing with his project. And I would say a very, very important cornerstone we have is a few years ago, so Portugal did not have any supercomputer. And we leverage supercomputer. There are supercomputers in Europe. You don't need to have a supercomputer infrastructure in your country to do big data, right? But it was a landmark they wanted to do. And so what we did was the University of Texas donated a few racks of a supercomputer we have there that started the first supercomputer in Portugal, called Bob. And that gave then action for Portugal to get funding to open its first supercomputer, the Eucalion. And there is an intimate collaboration with the Texas Advanced Computing Center, which is the very, very, very large facility at the University of Texas, and this new facility here. And so this was a big stepstone for Portugal to be in the map of the European HPC landscape. So it's pretty interesting. And this is my last kind of example was this year and last year we participated in GLAX. I mean, maybe some of you have already also participated in GLAX. It was here the last time in this island, and it's a community of explorers. And so it is pretty cool what happens there, and we became associated with it and contributing to exploring. Right, that's kind of what it is. And we now have a couple of missions going on. I'll tell you about one in a second. But as I told you, innovation is something that it matters a lot to the Portuguese government, and we focus a lot on that. Let me give you just an example of one program we started within JuliaEO in Portugal, which was to accelerate tiny Portuguese startup companies, tech companies, or deep tech companies. So we're not talking about apps, or we're talking about deep tech research-based companies. And we ran that for a few years, and it was simply incredible. I mean, the talent that was there, that is in this country, that was really needing to expand, and it was struggling to expand, right, in this tiny little market, and in Europe, which is very fragmented, etc. And all we did was providing soft landing to them, helping them to navigate the waters of the U.S. market, accelerate, get U.S. funding, and they went on their own. So it was pretty impressive. During this year, what we saw is for each dollar that FCT invested in the program, these companies were returning $33 back to the Portuguese economy. So that's pretty impressive, right? Just in taxes, hiring highly educated people, just by giving them the chance to go across the pond and accelerate there. And it's just incredible how these collaborations work. So have plenty of examples here, but I'm just going to focus on these two. So Feed Science, World Health. Those are, yeah. Yeah, of course. It was.
It's a really nice statistic, but I've always found it difficult to figure out.
Of course. So we wanted, back then, what we wanted to do is, okay, we're going to do this, we're going to try it out. It's pretty risky, right? Because success in startups is pretty seldom, right? Most of them fail. That's the reality. And so we said, we're not going to focus on impact now when we run it. We're going to run it. We're going to focus on impact when we stop doing that, right? And we're not going to measure the impact ourselves. So what we did was we went to one of the most prestigious economics university in Portugal, at the University of Porto, is FEP, Faculdade de Engenharia, the Economia do Porto. And we asked a researcher that her job was doing that, was kind of measuring impact, and said, look, we have this program, we have these companies that went through the program, like 35, 40. They're doing things, right? We know, we capture some metrics, but we don't know how impact can be measured. And she did it. So we funded her for a research project. She created an econometric model to do all of that. And she measured the direct impact, which is the sales of the companies before and after, how much venture capital they had before, how much venture capital they got through the program, things like that. That's very easy to measure. But then she went to the indirect. She also measured the indirect impact, which is taxes generated for Portugal, the hires that they did just because of the growth that they had by participating on this and all that. And she came up with this. So it wasn't us, right? So it's a paper that she published. So that's how it happened. So yeah, it's pretty impressive. But then what happened is we would love to continue this, but then the government shifted, and as you know, when governments change, policies change as well, and they wanted to go on a different route, and so we didn't do this anymore. But it was a pretty impressive program. We hope that we can do that in the future again. These two companies, VITEC, Sword Health, so are unicorns now. They're very, very successful, completely different from each other. VITEC is a big data kind of processing, real-time processing company. Their algorithms, when they first came to work with us, they wanted to be in Texas because they thought they could help energy, so utility companies, to manage their wind farms in real time. Because wind farms, as you know, you have to position the turbines according to the wind all the time. And what they did back then was they could give them feedback in real time with sensors and processing all that data in real time in their engine, whereas the current practice back then was at the end of the day, they analyze the data during the night, right? They put the computers working, and then the next day they would know what to do based on past, not ideal, right? So VITEC gave them the opportunity to do it in real time. But they soon realized, and as people who work with startups know that usually never end when you in the market you think you're gonna end. So they went to utilities. They're very, very interested, but utilities are very slow-paced companies, right? And so they took forever to make a decision. Yeah, I love this, but they never bought the product, right? It would take them a year, and startups cannot survive on a year time frame. And so they were so smart. We introduced them to some VCs in the Valley that introduced them to credit card companies, and they are now the #1 cybersecurity company in the world. So most of the Visa, MasterCard transactions in America are monitored by them. That's when you're trying to swipe your card and it gets rejected in Colombia, for example, because they're looking at your behavior, right? And this is not a typical behavior of this person to do something like this, so they block it in real time. And in real time means milliseconds in credit card, right? So that's what they're doing, and they're hugely successful now. They could IPO, but I don't even think they're going to do it. It's pretty incredible, their growth. And we're not responsible for that. They're talented, very talented, but we help them accelerate, tenfold, and it was just incredible. Sword Health is different. It's a physical therapy, online digital physical therapy company that is also growing same pace, also unicorn. And Portugal is a very small country, but right now there are like 7 unicorns in this country, which is impressive for the per capita is huge if you see the number of people. And Sword Health is one. They also went through the program. Both these companies were like 5 people back then, right? Now they are hundreds and hundreds. And it was the same, right? They accelerated through the program, and it was pretty incredible. They have soft landing with us, and they're now pretty huge. I wish I would take a job with them back then, and this was like 2012 or so. That would be cool. But anyway, we're super happy about that. And it does not happen overnight in this type of programs, right? It's a program that took ages or a lot of years. I mean, like I told you, more than 18 years to really produce deep results. And now, it's ongoing. And I'm pretty excited because on the 18th of December, the Council of Ministers of Portugal approved the renewal for another phase of the program, right? So this is public, not sharing any confidential information, and it's pretty cool. And the areas we're gonna focus on we're abandoning medical physics just because, it's so out there, does not relate a lot with the other areas, right? It's pretty successful, and there's not a lot of critical mass in Portugal. But we are continuing nanotech, advanced computing, space, Earth, with a lot of established. This is very tiny. With a lot of institutions in Portugal, and we have a new core area for the next phase, which is pretty exciting, which is clean energy. And as you know, clean energy relates a lot with advanced computing, with nanotechnology, even space Earth, right? There is so much, with that. And we're pretty excited with this new core activity in clean energy. Texas is very strong in clean energy, although we're known for, Houston is known for, oil and gas, but the reality is super, super big in clean energy research. We're going to focus a lot on hydrogen. And in terms of Earth space tech, what we did was, back in September, we had a colloquium at UT, and we invited there were 92 people there from Portugal, from UT Austin, discussing, and João was there, actually, and discussing what the future, what this area, what are the topics within this area that in the next 5, 10, 15 years we should focus on. Because, space Earth is huge, right? What is space Earth? What we're trying to do is looking from the Earth up, right, with some nanosats, trying to develop that type of technologies, but mostly using the data of satellites to solve Earth problems. So it's kind of with climate in a lot of different fires, for example, is a big thing in Portugal, a very important theme, things like that. And so instead of us figuring out on our own, being a top-down approach, okay, we're going to focus on space Earth on these topics. Instead of that, we wanted researchers, the experts, to talk with each other and tell us which are the areas you would invest in the future, right? And that's what came from this. The next 3 slides are the areas that they came up with. So probably, I'm not going to read all of them, of course. I'll give you, a few seconds to read, and I'm going to share this presentation with you guys, of course. But these are the areas that they come up, the topics that they came up with that we should focus in the future. So 3 big topics: terrestrial applications enabled by space, with these sub-topics here. Then, if you allow me, next one is technology for sensing and solutions in space, with these subtopics in it. And the third one is more on satellites, more up there, which is this one on technology for enabling space activities and engineering operations. Those are the 3 topics that we're going to focus on with these subtopics. And again, when I say focus on, opening calls for projects that we're going to fund, opening calls for people to get trained, providing training opportunities in Portugal, training opportunities in Texas, providing online training opportunities, exchanges, 2 to 6 months stays in Texas, up to 2 years, for example. And there's people working on these areas, right? That's super important. My last slide, because I'm running over my time, I'm sure, is, and then we can look in the breaks whenever you want. We can definitely chat about it. There are 3 opportunities open for the, if there are people in the room that work for Portuguese institutions, please be aware. One is we have a call for projects open this month. then which is for research projects in this area. So Space Earth is one of the areas again. We have Tech Launch, which is, I don't know if you're familiar with I-Corps in the US. So I-Corps is a National Science Foundation, started this program, now it's all over the United States. It's a customer discovery program for very nascent, not even startups, for very nascent research projects that they want to figure out if there is any market to the results that they have. And we cannot call it I-Corps because it's a trademark by the NSF, but we call it Tech Launch, but it's exactly the same with US certified instructors, all that we are. There is a call open right now for teams for that, to participate on that. And the third one is a mission. It's a mission with University of Bergen, with Harvard, Johns Hopkins, and UT Austin, which is called One Ocean Expedition Course, which is where we have 5 grants for 5 participants from Portugal, fully paid to do this, and we're looking for doctoral students, so graduate students, or even undergrad students in special cases that will go do some research doing this expedition, which is starts here in the Azores, goes to Iceland, and goes all over to different places, and to work on climate change, on modeling, on data. And we hope that we can, this is brand new, and I hope that, I wish I was 20 again to be able to go participate on this. But anyway, if you know any bright, it doesn't have to be Portuguese, it does have to be affiliated with a Portuguese institution or university or research lab or something, or company. If you happen to know people that could apply to this, please push them to our utaustinportugal.org website, and that's what I wanted to tell you. I'm sorry I went a little bit over my 10 minutes, but I'm during the breaks, etc. I'm available. We can chat. Thank you very much.
So hello again. It's not common, but this time I decided to actually do a presentation myself as well, to explain, to better place why the AIR Center has so much interest in Julia, and in particular in this community. And I titled the presentation, Challenges, Opportunities for Data Science and Computation. And you may wonder why data science and computation, 2 apparently different things, but they're more and more convergent, and the interaction between the 2 is more apparent than ever. So I'm going to talk a little bit about the AIR Center, just a very brief introduction, then talk about the opportunities that we see and the challenges that we face as well. So the AIR Center is, as I said earlier, it's a non-profit organization funded mostly by the Portuguese government, but has a lot of partnerships around the Atlantic. We are part of the United Nations Environment Program. We are a grid node, so we source data to them. We are an ESA lab, so we have our technical team works in close collaboration with other European Space Agency laboratories. We are part of the National Scientific Network for Computing, and so through that also for part of the European Computing Network, and the Marine Biodiversity Observation Network, the MBON, which is based in the US, but we have the World Secretary here we've had for the last 4 years. So starting with the opportunities that we see, I think nothing speaks higher than the Nobel Prize this year, a Nobel Prize for protein structure prediction, computational protein design, that was won by David Baker from the University of Washington, Seattle, expert on the field, but then by Demis Hassabis and John Jumper, who are experts in actual data science and machine learning. And so this is just an example where we see that this is an example of the opportunities that data science has at the moment. You name a field, name a topic, and data science can probably help. And in some cases can make a huge difference, as is the case here. And another important aspect of this is that machine learning is not something of researchers anymore. This chart is pretty obvious that the transition, so there is a growth, yes, great, but there is also a growth in the industry. Data science, or machine learning specifically, AI specifically, is reaching the public. It's in the industry. It's being used increasingly in the industry. So in other words, it has an impact, it makes a difference. And we are using it as well. We are very small. We have around 20 people, around 12 technical team only, in several areas: the ocean, space, and data science. And I'm going to go through some examples of our work, very small examples. We are also very young. We have 5 years old. The Earth Center is only 5 years old. And these are examples where we use data science to help local communities and local economies. And the reason I'm talking about this is to help establish bridges here so that you know what you're doing, we know what you're doing, and we can find more bridges for collaboration. We always work, this is in our DNA, always work aligned with Sustainable Development Goals. And these are the ones, these 10 are being addressed right now with the projects that we have going. So an example of support, as I mentioned, local communities, in this case a municipality here of Langadui region. The city center is protected by UNESCO. You cannot put solar panels on the buildings. So they also don't want to compromise that and compromise the possibility of the residents to have access to this kind of technology, of clean energy. So they asked us, we need to install create a solar farm. We need to install it somewhere on the island. Where should it be? We went to 10 years of solar radiation, measured by satellite data, and we gave them a map, produced a map of actual radiation on the island, radiation levels, and they can now make an informed decision. Supporting livestock producers, cutting a very long story short, there is a fungus in the pastures that sporulates with certain meteorological conditions, and then the cows ingest that with the grass, and that has very nasty health effects, leads to permanent damage on the liver, sometimes death, and sharp reduction in the amount of milk produced. And so we created a data pipeline that analyzes data in real time and provides alerts to the farmers in real time. So every hour they can check what's the status, what's the level of risk in their pastures, and simultaneously we're doing collecting samples and checking what's the reality to do the validation, what's the reality in fact on site. And based on this data now we can improve the algorithm and the state of knowledge of science based to have a better, an even better prediction algorithm to measure that measures the risk. Supporting farmers as well, vineyards, health. There is a small economic aspect to this too. The vineyards here on the island, they are not new, but there is an intention to increase them, and the farmers don't have a lot of data about how diseases that affect the vineyards progress and affect the vineyard here in this weather, in this climate, with this soil, etc. So then we set up a project, and we're giving real-time data as well, information about the risk of health for the vineyards. And then finally, for fishermen, so these, as you see, these are all local and very important community projects that's supporting local communities and local economy. In this case, fishermen, this project increases the operational efficiency and pollution avoidance. So it's the system is called Custodian. It's a set of it's a data pipeline with hardware as well that we built in the last 2 years with a project that allows fishermen to put specific sensors for location on the fishing gear, on the buoys. So they always know where the buoys are if they are it reduces the chance that that equipment is lost in the sea, and also helps them recover them faster. So they lose way less hours, they use way less fuel, and they have more income because they don't lose so much gear, which is quite representative for them. 10% a year in gear loss reduced. And at the same time, reduced pollution in the sea and the ghost fishing by having nets lost in the sea. The last project I'm showing now, supporting scientists and the industry now in the ocean in general in terms of global monitoring of internal waves. I'm not going to talk much about this because there will be a presentation in the afternoon specifically about this, but that's just a very new project that we started with some funny twists that you're going to hear about, but again, supporting scientists and potentially some parts of the industry. So now data science and high-performance computing, the age of AI. So computing is a universal tool of science and engineering. I mean, and this is aligned with data science, puts it right in the center of what's, at least to a lot of people, is very interesting today. We can do simulation, data analysis, AI, and to make sure that the greater community around the Atlantic has access to this infrastructure, we're creating something we call the Atlantic Cloud, which are basically shared infrastructure. We have our little data center here, but so Brazil, LAMS, and other institutions in Brazil have joined have helped us to create an hybrid cloud. So we join efforts from different places. We joined all this infrastructure with a single point of entry, and we can have several institutions using the same resources, maximizing, optimizing the use of those resources, and following that also a lot of practices and standards for data storage and data handling, etc., which is really important too. It's not only have data, we have to work at the scale of the Atlantic, for example. We have to measure things the same ways and have data stored in similar manner, etc. So that helps us work together, basically. So we aim to have a lot of infrastructure spread throughout our partners, so throughout the Atlantic. At the moment, it's only here in Terceira, Portugal, and in Brazil, in 2 institutions. And one thing that we installed here out of necessity was an IoT network, a LoRaWAN network, a set of antennas, gateways, and then you can put a lot of sensors on that network to read real-time data. We're using this for several projects now, most of the projects I mentioned before. We had really good results. We even published a paper about this, and we are expanding this throughout the islands in the Atlantic, in the Azores and potentially in other parts of the Atlantic, coastal areas and islands. This LoRaWAN technology is super low cost, low bandwidth, but also very low power, which means that each sensor can the battery for each sensor can last 1 or 2 years. So now to the challenges. The main thing about the challenges are energy and environmental footprint, and of course the costs associated with the infrastructure and the energy that it uses. We see computing efficiency as a paramount thing to deal with if we want to be responsible. We're doing data science. We want to do data science at scale in the sense that not to run large LLMs, but in the sense that we want to run ocean modeling, for example, regional models, etc. And we need to be responsible. After all, we are a member of the United Nations Environment Program, and we make sure by our decree internally, we have to work to pursue the Sustainable Development Goals. So we cannot say one thing and do another. So that's one of the reasons Julia is so important too, because it's a language that in principle, it can be more computational efficiency, so power efficient. We see 3 areas in which there is a lot of work to do, and some of them have a lot of potential. Software. Potential increase in efficiency by over 1,000%, probably way more than that. And Julia can be a big part of that. You, as developers in Julia, can have a huge impact on the power efficiency of computing. Then chip architecture, potential increase by tenths of percentage points, probably a lot of a large impact as well. It's something that, unfortunately, I mean, the Air Center is not aligned with this, and probably we're not going to be working on this. Also, Portugal is probably not the country to do this kind of work. And then we have data center setup. So potential increase in efficiency by 40%. That will be neat because that's how much data centers use. So 40% of the energy data centers use is just for cooling. So it's not for the essence of the data center. So in terms of software, we can do better code. We can use better algorithms. We can create new and improve the ones that we have. We can use better tools. A lot of people, you know, for example, one of the things I like about Julia is this coherence that you can do Julia, you know, turtle after turtle, all the way down. It could be Julia. You don't need to resort to other more performant languages. When we use Python, you know, we really like Python is nearly an API most of the case to then for C or C++ or Fortran in some case. So using in a lot of instances very old code, and probably not always the most efficient way of working. And this is, you know, somehow troublesome when we put things in production and we want to use them, you know, minute after minute, year after year. And so, but the problem here we find is like, it's not really sexy to do the same thing, just better, right? So we find it hard to get funding to do, you know, to just rewrite the same or similar algorithm with different tooling. This is part of the reason why I personally appreciate so much of your work, because you believe in something and you just go and do it. And through that personal effort, you end up creating, in the long term, a more efficient system overall. But if we could create projects to identify some bottlenecks and convert this to Julia or whatever tool. I mean, we don't use only Julia, we use everything, and but we try to use efficient tools. And we always strive to use the most efficient tools for the job. For example, APIs, we do Go. Everything that's like really hardcore for a lot of thousands of users potentially, and it has to be run really fast, has to have a good environment for development. We use Go, yeah, sure. But for the science part of things, we try to use Julia as much as possible so that you can have the scientist all the way through the user. And you don't have this throw it over the fence problem, and every time there is iteration, that takes a lot of time, and there's a lot of, gives a lot of headaches to everyone. So we see that Julia has a huge potential in this arena. So that's part of the reason why we are organizing the JuliaEO for 3 years in a row here. If you're here, no need to scan that because that's to register to you to attend online. So in terms of computing efficiency, in terms of hardware, we have to look at other architectures. That's as much as here at the AzoresTV we can do. We're not going to build new chips or anything like that. We're not going to be involved in that in any way. But we can look beyond x86, which occupies like way over 90% of all computing and all data centers. We're looking at ARM, we're looking at RISC-V, we're definitely looking at GPUs to increase our efficiency, and in particular, energy efficiency. I mean, so why GPUs are so important? Because they allow us to do several things at the same time. So with the same amount of power, or sometimes even way less power, you can do many more tasks. You can do different tasks, you can do all sorts of tasks, you can do simpler operations, but the instruction sets for GPUs are also growing a lot. So GPUs are definitely a way to increase the efficiency of our code, and we should strive to do that. And that's another advantage of Julia, because it allows you to do that in a much simpler way and proper. And this is specifically useful for Earth observation, because I mean, original GPUs were created for matrix operations and for displaying and for ray tracing, etc. So doing the same operation many times in many the same operation simultaneously in many cells really fast, because it does the operation in many cells at the same time. And so it's way more efficient. And if we compare the gigaflops per watt, so the work versus the energy, the electric, we can say the electric energy uses to do that work. GPUs are way more efficient. So if everything we can give to the GPUs to handle, we should do that. So now come to the third topic. We talked about software, we talked about the hardware part, and we talked about the data centers. I mean, and data centers are great. We have one. I mean, we love it. Our data centers work like in the limits of physics. They have for a while. We keep expanding that. But they also not great, because they use 40% of their energy just for cooling. 40%. I mean, we could do 40% more compute or use 40% less energy, right? And in a world where you're using so much energy already for this, like 2% of the global electricity usage is for data centers. It's over 1,000 terawatt hour of energy. That is significant, and we can't ignore this anymore. In fact, one of the limitations for more compute, and nobody sees the amount of compute in the world reducing, it's the availability of energy. So, for example, Singapore created a moratorium on data centers in 2019. So they said, well, we don't have land and we don't have energy for this kind of thing, because a lot of companies were creating data centers there as like a hub for the Asian market. And so they put a stop to it. Microsoft is reactivating a nuclear power plant to power an AI data center, specifically AI data center. So for those who don't know, AI consumes even more energy than traditional computing. Amazon, Google, and OpenAI are investing in nuclear power. Current construction of a data center in the US are adding a load of 75 gigawatts extra to the grid in the short term, which is around 600 terawatt hour per year. This is equivalent to the energy that Brazil uses in a whole year. Brazil is a huge country with a population of nearly 300 million, right? From now on, we're adding this per year and might get worse. So it's not negligible, the amount of energy that's being used, and the fact that data centers could consume 40% less if they didn't need cooling or did cooling in a different way. It's very significant. And this is something that we believe that we could help with. So we created a startup called @Depth that is a spin-off of the Earth Center, and we are mentioning this publicly for the first time. So this startup I started working in this in March last year, more or less, like on my own time. And I just went back to basics. Like, so what's the problem here? You have electronics that are generating a lot of heat. What's the best way to extract that heat? And it turns out that if you think about it properly in terms of basic physics, right, you're blowing air to that. I mean, air is actually a thermal insulator, right? So it's probably not the best way to do things. And then in order to get more efficiency or more capacity out of the cooling, we add more speed to the fan. So we spray the air with higher speed, so a higher rate. And so if you walk into a data center today, like just the noise of all those fans working is incredible. And you know that 40% of that energy is just for that, 40%. So we started doing things from basics very differently. And so we're trying to create a next generation cloud. You know, as Marco just said, 95% of the startups fail. But we're happy to be working with them, with the UT Austin Portugal program. In particular with the Texas Advanced Computing Center, which when I visited in September, they are very into, and they have been for a while, into ways of doing more efficient computing, in particular immersion. And so we are using also that technology. And I'll go into more details later. So our vision is a world where cutting-edge computing power and environmental sustainability are in harmony. And our mission is to accelerate that process, whatever means. And so for that, our main goal is to eliminate the waste of water and energy. I didn't mention water before, but data centers consume a lot of water as well. So we want to reduce the ecological footprint of data centers and create a security risk, security-first cloud for data and model sovereignty, because it's another problem. Data centers are not like 8,000 all over the world, but if you want to choose where you want to put your stuff, there's always a lot of limitations. And your data and your models normally end up elsewhere in places that you don't necessarily want or not on your country most of the time. So our approach is to create small compute clusters distributed throughout the world with 40% low energy consumption. So we go for power user efficiency 1, which is the best you can have. So all the energy you use is for compute, not for cooling. Data and model sovereignty, because there are so many, there's relatively small clusters. You can, and they are modular, you can make them larger or smaller depending on the needs and the potential of the site. And you can put it in your own jurisdiction, most likely. We can also have, because our cooling system is so efficient, you can have extreme compute density, extreme power, equivalent to a rack with 400 watts, which is like 10 times more than what a medium rack is today. And we also have far lower capital expenditure, and it's modular and scalable, and it also allows for really fast deployments. So we use this kind of solution where you have imports where there is already security, there is already network, and there is a lot of power available, and you can plan long term. We're installing these small pods with more or less modules or pods, and the cooling system is simple. We're using immersion, which some data centers are starting to use as well. This means that the server is itself inside of a liquid, and so the transmission of heat is virtually perfect to the box, and then the box directly to the ocean. And this results directly in minus 40% of energy consumption, so minus 40% of carbon emissions. And if you're worried about warming up the sea, I mean, that's virtually impossible. The sea is actually, the ocean is the planet's heat sink. And you have, because this is modular, in some ecosystems you might be able to put, one module only. In other places you could put 1,000 or 10,000. Of course, our goal is to not harm the ecosystem. But by default, we're already reducing, imagine, 40% of the carbon footprint. So here you can have, so these are part of our own data from the first tests. On the left-hand side, you see the traditional air cooling, where you have so the spikes in pink, the spikes, I was running benchmarks to take the processor to the limit. And so the processor runs on a baseline, a thermal baseline around 60 degrees, and then goes to 85, and 85 is cut by security, so it's throttled down so that it doesn't burn. So you also lose some cycles there. And then once you immerse it, the temperature baseline is reduced to 30. You have a much smaller delta, and no matter how long you run the benchmarks, you never go over 44 degrees. And this is passively cooled. So no energy for cooling. The energy is just used for what it meant to be, which is what we want, the compute. So water consumption, we use 0 water consumption. Data centers in general use a lot. So a reference here in 2014 alone, and this was quite 10 years ago. The amount of water used by the data centers in the US alone is enough to irrigate an area equal to Germany and Poland combined with 1 centimeter of water. You could cover 2 countries, large countries, with 1 centimeter of water. This was 10 years ago. Or you could hydrate the entire population of Africa and Asia for 1 year. So again, and this is normally good fresh water, so again, not negligible, and our system does lots. So it's very hard to find really good data for a long period of time about data centers, but we found some good data for Germany for this period 2010 to 2017. And the summary here is that of this plot is that if Germany had used our solution for all their data centers, they could have run their data centers with the same energy for 4 more years. And they could have saved hundreds of tons of CO2 emissions. We're not saying that our solution is going to replace data centers, not at all. I mean, we're going to be in the edge, we're going to have small clusters. It's not the same, but it's a complement that it's moving in the right direction. So the offer will be virtual machines, containers, all the normal offer, but in a zero trust security network. And that's not easy to find nowadays. And ours is built like that. It allows most companies or countries to have data and model sovereignty. You could have things where you want them because this is built to put in ports, to install in ports, or if you have a flowing river or a large lake, you can have this in your backyard if you wanted. You could have this as a private cloud if you wanted, or you can have this as a normal, for a public cloud, our cloud. And you can have extreme density. Serious density, you could have up to 10, well, at least 10, but probably more. 10 kilowatts per one unit, one server. In water up to 35 degrees, so that's like the highest temperature water in the sea, and that's like in the Singapore area, for example. You could have these. It's also secure, actually super secure by design as well, because it doesn't have, once it's deployed, there's no human contact possible. There are sealed boxes underwater, so nobody can go there with a USB flash and stick it on and do something you don't want to happen. So if it's working, if it's deployed, there's no human access, only via the cloud, only via the infrastructure. That's really thumbs up for security. But also, you can have systems like if something really strange happens, if something once goes there with a submarine and tries to get it or something, we control, we have a lot of sensing on this pod, and so we could just inundate it. And the replication, it replicates automatically by the cloud in other places, and just all data is lost and it's recoverable. So if somebody will take something, it will just take metal, basically. And so a lot of operational advantages, carbon emissions are much lower as well. So this is all I had to say. So in summary, I mean, the Air Center is working normally with local communities. We believe in Julia for all these reasons that I mentioned. We're working in the software part as much as we can. We're a very small team, but we organize this event and we're spreading the word on Julia as much as we can. Now we started a project with Nigeria, for example. And so we don't have a lot of resources, but we do the best we can, and all the resources we get are for this. So software, this is the front. We work on software. We're not working, or we don't see that we could do any contribution on, or Portugal could do any contribution, or most countries, by the way, on chip development and chip fabrication, etc. But on the data center side, we could. And this approach is great when you think about the Air Center spreading data centers across the Atlantic and reducing in a responsible way, let's say. I mean, the most responsible way possible. So thank you. That's all from me. Super glad to have you all here again. And you won't hear from me more in terms of content, just for like logistic stuff. So now it's with Adriana Ferreira. She works at the Air Center. And so this presentation is going to talk about now the internal wave service, something we're starting now too.
Okay.
But after lunch, it's no more Air Center. It's just about you. And all the other days are just about you.
Okay. Hello, good morning. My name is Adriana, and I'm a maritime applications developer at Air Center. My presentation is about internal web service, which my data science team and I developed, and we are still developing. I will start by introducing internal waves, and then João Gonçalves and JuliaEO will talk about the algorithm and used in this service. Purpose and overview. I began this presentation by drawing an analogy to a book based on a true story, Moby Dick. In this book, we find the following quote: "When beholding the tranquil beauty and brilliance of the ocean skin, one forgets the tiger heart that pants beneath it, and will not wringly remember that this velvet paw but conceals a remorseless fang." Indeed, the surface of the ocean can conceal what lies beneath it. In Moby Dick, referring to the giant white whale that in the end overturns the vessel. A perfect analogy can be drawn to the lesser-known internal waves, which, hidden within the ocean, are often much larger than surface waves and play several critical roles in the ocean, from transporting nutrients to influencing the global climate or damage structures. But what are ocean internal waves? One way to introduce them is by imagining them within the ocean, occurring between two layers of different densities along the Picnoc line or Thermoc line, often with larger vertical amplitudes than surface ocean waves. They can reach more than 100 meters. The movement of internal waves generate orbital particle motions, which at the ocean surface form slick bands that make them visible both to naked eye and in satellite images. In this photograph, in Cape Cod, we can see the rough and smooth bands of an internal wave. Here we have a graph that is illustrating various ocean phenomena and their temporal and spatial scales. Near the middle, we have internal solitary waves, and the arrows point to recent studies of this phenomena, which propagates over a space and time. For example, in case of Meng et al. 2022 and Magalhães et al. 2016, the waves propagate over long distances, 1,000 kilometers, and can last up to a week. But why are they important? Internal waves are crucial to understanding ocean dynamics and their broader impacts on marine ecosystems, climate, and human activities. Here are the main reasons why they are important. They transport energy, which can give rise to other ocean phenomena. They contribute to mixing, redistributing heat, nutrients, and gases between the ocean layers. Internal waves are one of the main phenomena contributing to vertical mixing in the oceans. They transport nutrients by promoting mixing. Internal waves transport nutrients from the deep ocean to surface layers, fueling primary production. These processes support marine food chains and biodiversity. They contribute to climate regulation. Internal waves contribute to the ocean's role as a heat and carbon sink by facilitating the exchange of heat and gases between layers. Their influence on ocean circulation impacts the global climate system. So they have a connection to global ocean circulation. By influencing the mixing and transporting of water masses, internal waves are connected to the thermohaline circulation, which is a major drive of global climate systems. They can also make coastal impacts. Near coastal areas, internal waves generate upwelling events that bring nutrient-rich waters to the surface, enhancing the productivity of fisheries. They can also contribute to coastal erosion or sedimentary suspension. And they can influence engineering and submarine operations. Internal waves create strong currents and turbulence that can affect underwater structures like oil rigs, submarine cables, and pipelines. So, internal waves are essential for understanding the physical, chemical, and biological dynamics of the ocean. And where can we find internal waves in the ocean? This is the most up-to-date internal waves world map that I'm aware of. It was created using MODIS images collected between August 2002 and May 2004, manually. While I know it is missing some hotspots, such in the middle of Pacific Ocean, it remains very complete. The red dots represent the mass centers of the internal waves in the ocean. Our goal is to support researchers by delivering detailed analysis of internal wave hotspots, thereby improving our understanding of the Earth's oceans. How? We created the Internal Wave Service. The data we are using for now is from Sentinel-1 that operates in SAR mode and therefore is not affected by clouds or atmospheric conditions. This is optimal for regions where clouds are common, such as the Azores area. At the moment, we are using the wave mode, which operates primarily over open oceans with VV polarization. It captures 20 kilometers by 20 kilometers vignettes at a resolution of 5 meters, acquired at a regular 100 kilometers interval along the orbit. However, Sentinel-1 wave mode does not operate over the entire ocean. For instance, in coastal zones, the satellite typically uses other modes. In the future, we plan to add other modes and other satellite data to our service. This synergy will allow us to calculate relevant parameters. But what is this service? Every day, the system processes all the images and applies our machine learning model. The model classifies the images as either containing internal waves or not. Images without internal waves are deleted, while those with internal waves are added to our database. This greatly facilitates the work of researchers who previously had to manually analyze thousands of images to identify a positive case. Here above we have some examples of internal waves, and below without internal waves. Below the first images is wind patterns. The second image, it's a boat. The third image, it's a rain cell and a thermic front. And the last one is a thermic front. Which machine learning model do we use? We tested some machine learning models and created a competition on the Kaggle platform. To support this, I manually labeled nearly 1,300 images. The winner was Gilberto Jr. from NVIDIA in Brazil, and we had the pleasure of personally presenting him with the prize. We are currently implementing his model using the new dataset we have, which consists of the images saved by the algorithm. At the moment, we are supervising the results using the validation platform. I am the expert handling this task, but in the near future, we plan to have more experts assisting with it. In just 3 months of the data, we have more than 1,000 images classified as positive. For every positive image, we keep one negative image to ensure balanced examples for retraining the machine learning model. Here is an example of an internal wave classified as positive. I have no doubts that it is, so I confirmed it. To bring together internal wave experts and improve this service, I'm excited to announce that the Air Center, in collaboration with University of Porto, is organizing a workshop with specialists from various fields. We already have confirmations from these institutions, IFRAMER in France, NERSC in Norway, the University of Southern Mississippi, and CIMAR in Porto. If you are interested in joining, please let us know. Now, my colleagues will present the program and the model we are using.
So, these images that Adriana was talking about, they're used to validate the train model, and will be used to train the model after the code created by Gilberto is integrated into our existing code. And I will now show you the winning model and briefly explain what it does and pass over some of the lines. So basically, this is a binary classification task that, as we can see here, achieved a quite high score. There's obviously some steps before this, but here we have the data loading, and we can see that an extra column is created to add the full file paths of each image. But skipping to the custom dataset class that handles the images, here we can see, for example, that uses the image open to load the images and then convert them into RGB. Then it is used the TIM library to load a pre-trained deep learning model. And we can see that the images are then standardized and resized to meet the model's requirements. That model is then moved to a GPU and set to evaluation mode for inference. That inference is divided between training data and test data, respectively. As Adriana mentioned, she manually labeled 1,300 images, half containing internal waves and the other half without internal waves. After augmentation, that number increased to approximately 5,000 images, and out of those 5,000, 70% are used for training and the remaining 30% for testing. Here we can see that the code defines the data set in the data loader. at the beginning, for this case, for the training data. And then it uses the pre-trained model to generate feature embeddings for each image. Then there's a loop, a batch loop that appends the processed features from each batch into a list and then combines it into a single array, and pretty much does the same thing to the test data. Then the code defines the XGBoost parameters. There's a bunch of them, but also a way of optimizing the performance by using a GPU. And then the model performance is evaluated by a cross-validation score. We can see that Gilberto used the area under the rock curve metric, but also the stratified k-fold that provides the train test indices to split the data in train test sets. Here we have one of the outputs, which is the validation score. We can see that it's quite high, which means the model has an excellent performance. After the cross-validation, the XGBoost model is trained on the entire training data set. We have the features and the labels, and then predictions are generated for the test data. Basically, for each image, for test image, that function predictproba generates the probability of that image belonging to a positive class. In this case, being classified as 1, since this is a binary classification. Oh, yeah, sorry.
I'm just curious, is the data set still Canal? Is this something that people can still...
Yeah. You can see the code. The competition is closed, but you can see the code that, all of the codes that were submitted and the outputs. And
What was the competition called, sorry?
Internal waves.
Then those outputs are saved into a CSV file, and as I mentioned, this code will be integrated into the existing code, will be trained with the new data set, and then the internal wave service will be available with near real-time updates. But as you might have noticed, all of our code right now is in Python, and actually one of the next steps includes moving the code from Python to Julia, because we are aware of the advantages of using Julia for training and inference. We have notion that it's ideal for intensive workloads, but also for projects that require scalability, that optimizes computational resources usage, which means that we're dealing with a potential reduction in time per iteration, which enhances training and also enhances inference. And we have, for example, here, one of the examples that happens currently with the Gilberto's code. In one of the outputs, there's a warning message about mismatched devices because of the CPU and GPU when running the XGBoost. And we know that Julia has packages that are libraries that are optimized for GPUs and inference on GPUs. So one of the next steps also includes this migration, let's call it, from Python to Julia. And now, João.
Hello everyone, my name is João Gonçalves. I work for Air Center. I'm currently the IT specialist, and I'm also a software engineer. And I help the team to design a system where we have a data set of these Sentinel-1 imagettes that shows us the sea roughness. And the main challenge we had is we wanted to build a data set, and we wanted to automatize as much as possible getting images in a fixed in a periodic manner. So we built a background service. This service periodically fetches the S1 vignettes show with the sea roughness from our defined sources. It uses the machine learning algorithm to identify internal waves, and then, as was mentioned before, it saves an internal wave. For every internal wave it stores, it also stores a negative image to give our data set some balance. And what we wanted to achieve with this is, so we have a growing data set. We have this automation to pre-label the data, and then we wanted to build an application that would let an expert and multiple experts in the future to help us verify these labels, so we have the most accurate data set as possible. So for that, we've built an application. It was built with Go. This is a web application, and we wanted to have a user-friendly interface where we would show every data point in our data set and allow the experts to review the images, analyze the sea roughness, and then confirm if if the label that was attributed by the ML model was accurate or not. So this is a very simple interface. We wanted to make it as simple as possible and deliver it as fast as possible. So we have, we wanted to make the life of the expert as easy as possible, to navigate from one image to the next and validate a large number of images very quickly. So we built a very simple interface for that, where the expert can open a list. From here, we see that the interface is divided in several lists. The expert can select the list where there is unverified images, and then open one of them and click next, 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 and verify and confirm each one very quickly. So this is what we have done. This is the current features we have. We also created a web interface where we can see the positions on a global map of every internal wave event. Right now it's showing only the ones that were verified by an expert. And it's also possible to click on each event and see the sea roughness vignette. And in the cases where for a small area we have multiple vignettes, it's possible to select each one with the user interface. And this web interface, this map web interface, is continuously updated as soon as an expert verifies new data, confirms new data. So I've spoken about the features that are currently implemented already, but we have some features in the pipeline. Right now, we are working on multiple users, allowing multiple users to verify the labels in our images. And we are working on a consensus algorithm. It's still early stage, but the idea is that we want to have multiple experts logging in our application at the same time. Each one of them having automatically attribute to them a list of data vignettes for them to analyze and verify. And each one of them will give a vote with their sense of their verification, and then we will have a validation system that will use this consensus algorithm to basically check if there is a majority vote, and if there is, it marks the image as confirmed. If not, it still waits for more votes until it has either the minimum number of votes or has reached the consensus. And then this is what we are working on also. We want to have a way for experts to collaborate. We have, Adriana has already showed us some images where there is a lot of doubt. because it's not, some images are not easy to identify if there is an internal wave or not, and some experts might want to, you know, add their opinions in a collaborative manner. So we want to give a way to add text comments from experts for every image, so a collaboration can be had. And then maybe it's easier to validate the data when there is a series of comments from experts, and maybe it will be easier to verify the most difficult cases. That's it from me. Thank you very much.
Connection, it's not. Can you try with this one? See if it's. Okay. Yeah.
Okay. Hi everyone, my name is Iga Szczęśniak. I have been working at the Air Center for the past 2 years as a project developer, but now I work at the European Space Agency as a space innovation engineer in headquarters in Paris. Today at JuliaEO, I wanted to share with you a real-time alert system that I have developed fully in Julia over the last summer. So the alert system is for vineyards monitoring using the data from the Internet of Things sensors that we have installed in 4 vineyards on this island in Terceira. Yeah, so the system is using meteorological data from these IoT devices, and later there is a model of a disease that attacks healthy wines. It's called downy mildew. It's a fungal disease that attacks healthy wines and is driven by the weather. So we have developed a model that calculates the risk of the infection of this disease. And it was possible to use only one language for the model itself and the front end as well. And I'm going to share the results just right away. Just wanted to say that in general, people do not care about data and algorithms, but rather about knowledge and information. So this is really useful skill to know how to do a proper data visualization or a dashboard or this kind of real-time data application. And it's worth to know how to do this in Julia and the available tools and frameworks, and also their pros and cons. So this is how the dashboard looks like. It has 3 main parts. First of all, there is a map of the locations of the sensors. Then there is a dashboard displaying meteorological data, such as temperature, humidity, precipitation, and so on. And finally, there is a model of the primary infection of downy mildew, which we could filter by sensor or vineyard in this respect. So the idea is that when the certain weather conditions are met. In this case is 10 degrees of Celsius of temperature and 10 millimeters of accumulated rainfall within 2 days in a row. There is a risk of the infection of this disease, downy mildew. It's a primary infection, the stage of the disease. So we have calculated this in Julia. Also tested various rainfall thresholds because of the like uncertain weather conditions on this island. Some wine producers reported that they follow the rule that 10 millimeters of rainfall is relevant in their property. Some of them were saying, oh no, 7 is that what we are looking at, or 5. So we have developed 3 scenarios. And last but not least, this model is only relevant when the plant itself has 10 centimeters. So the model should be run from September till March every year. Other than that, the plant is not high enough. So the sensor send hourly data to the Air Center server, and then I download the data and do all these visualization steps. All of this has been developed in the scope of Vinhas Terceira project that Jean mentioned previously. So the objectives of the project were to create real-time monitoring of the vineyards in Terceira Island and to develop data visualization and automated alert system for this disease downy mildew. Also to give the wine producers the opportunity to use modern tools and take more informed decisions based on first sight of the service, which they didn't have until now. The SOFI system is based on the LoRaWAN communication protocol. So the Internet of Things network that Joan mentioned previously is also based on this LoRaWAN communication protocol, but the SOFI sensors are slightly different. They are powered by not batteries, but by the solar panels, and they measure more things, basically. The other network measures only temperature and humidity, while the SOFIs measure also precipitation, wind speed, wind direction, and solar radiation. So more things to measure. Here is more pictures of the SOFI sensors and how did we deploy them. So as you can see, this is a small device powered by the solar panels, and we place them in Biscoitos. It's a village in the northern side of the island where people typically grow their wines, and this is very characteristic. They grow the wines inside the fences made by the rocks, as on the last pic. So in this pilot project participated 4 vineyards. However, I think I forgot to mention, but the device itself is low cost, is less than 100 euros per each. So I believe this solution can scale up for other vineyards, for other islands. I mean, for example, Pico Island, that is really known for growing wines, or Portugal mainland, where there is the Douro Valley, or even other countries or wine regions around the world, like South Africa, for example. Also, I believe we could track different diseases if we know any specific information, how they develop. So this is a pilot project on how this prototype could work using Julia. Why did I choose Julia for it? So in general, Julia is good for working with matrices and vectors, and we know that geospatial data are made of those. It has a common an ecosystem for common geospatial operations, so it's fine as well. And Julia is a modern language, and it has a built-in package manager called REPL, which is easier for me to manage the project environment, for example, and there is no need to use any external software such as Anaconda, for example. As mentioned before, Julia solves two-language problems, so it could give us the really high performance, but still keeps the user-friendly syntax, so it is easier to develop in. And last but not least, the user-friendly syntax that is based on mathematics, and this is really a good thing when you need to do some calculations, because it's I found it easier compared to other languages. For my project, I have used Dash.jl framework. It's a Julia framework for building interactive web-based data applications, and eliminates the need of switching between different programming languages or tools. So there are other frameworks available. There's not only Dash in Julia, there is Bonito.jl. For those of you who know Maki, that's the natural choice. And there is also Genie. I didn't choose Genie because it was commercial, and I realized they go rather in this direction, so I wanted to keep in Dash. I didn't choose Bonito because at the time I realized maybe it was not enough documentation, so I decided to go for Dash.jl, and I really like the experience. The key features of Dash is that you can create the visualizations like all kinds of charts and plots and maps and tables in it. It enables real-time data updates, so it is important when creating a real-time alert system, for example. You can be also creative with the layout. It's not predefined for you, so it can really look like whatever you want to. And it enables interactive elements. This is also important to, for example, avoid the oversaturation by data and make your plots clean and nice for the end user. How did I start working on this? First of all, I look at the Dash for Julia documentation. They have quite a nice documentation, and they have many examples, including the minimal Dash app. So that's the thing that you can run on your local server and have the sense of how does it work, and then add the things on the top of it. So with this guide, I would say, it's really straightforward to develop your own data application or alert system. And I attach here the link if you're interested to see it afterwards. Some visual elements of Dash.jl that I believe everyone at some point will use when developing the data app or alert system are graphs. So in Dash, we could create really nice interactive and what's important, responsive graphs. It's built on the top of Plotly.js, and it for now supports over 35 graph types, including more fancy scientific plots as well. So you can choose between different ones. Other element that I found useful is a drop-down list. So it's really useful when you want to select your data by a certain variable or parameter or column. In my case, it was sensor number, so the vineyard number itself. so that the wine producer can really look at his own data, his own property. Another thing commonly used when creating a dashboard is a slider. It's useful when displaying a range of data or a time series of data and in general handling dates. And this, I must say, I didn't really like in dash.jl. I mean handling the dates. So the numerical slider was kind of okay, but the date slider, I didn't really like the experience. So in the end, I decided to have the buttons with the time range in my dashboard instead of having this slider. So you might take a look at another frameworks like Bonito or Genie. Maybe they have a nicer slider for dates. Another thing that is useful is for geospatial people, I believe, is a support for Mapbox. So to bring location technology to your data application. We use it to have a map background behind the data points, for example, or coordinates. So in my project, I have used the satellite view and the streets view, and it's possible when using Dash at the moment. Another step was calculating the 10-10 model. I did it in Julia as well, so that was really convenient that I didn't have to switch between different languages or tools. I just really had everything in one project and keep it clean. So that's how it at the moment looks like. The rainfall and the temperature thresholds are displayed, and then you can see respectively the alert if there is a risk of the infection of this disease, downy mildew. So the farmers can really take a look if they should take any preventive measures to their wines if they want to. So to create this thing, we had to, first of all, talk with the stakeholders, the Smart Farm Collab organization, which is farmer organization, and the wine producers to understand their needs and what they want to really extract from data and what information they are interested in. Then I designed the dashboard layout, so how those all elements are placed on the web page. Afterwards, I created the graphs and visualizations to display the weather data. And afterwards, I implemented the the model of the risk of primary infection. Add interactive elements, so all these drop-down lists, buttons, etc. And finally, we deploy it on the web. If you're curious to see the dashboard live, the first QR code is here. The second one is for the code. I must say that the dashboard better looks like on the laptop or a bigger screen than the phone, but that's maybe not the best in Dash, that it doesn't look very pretty on the phone on the small screen. Other than that, we use Julia for validation of the measurements from Internet of Things network. It's a network of around 50 sensors here on the island. So we have a paper about detecting fungus spores in the fields, where you can find the results of this sensor validation. This also has been made in Julia. So my final thoughts is that Dash can be a way to go to build interactive and web-based dashboards, but you may take a look at other alternatives like Bonito or Genie, because they might work better for you. But I found, in general, my experience with Dash really cool. Yeah, Julia is a good choice for fast prototyping, and especially if you want to test a solution that is coming from science and from research, because it's easy to write calculations and you can keep only one programming language. Also, Julia has a mature package ecosystem to build this kind of stuff in various fields, not only geospatial, of course. And before I finish, I wanted to share with you a little bit of my current work at the European Space Agency, because I think like some of these things might be relevant for you as well. Right now I work on the Discovery and Preparation program at the European Space Agency, and this is a main program for finding the novel technological solutions for space at ESA and preparing the agency for the future. So we run this open call where everyone can submit their proposal, and then it will be evaluated. And then we evaluate all of those research proposals and give the funding to the ones that we see a lot of potential and also novelty. So the idea is that we really take a look at the novel solutions, even of low technology readiness level, but the goal is that those solutions need to be novel. So at the moment, we have 3 implementation schemes for studies, early technology development, and co-sponsor research. Studies and early technology development are up to 12 months, when co-sponsor research could be more, because it could be also a PhD project as well. So you are really welcome to submit your proposals as long as your idea is novel and related to space technology. We don't necessarily, we of course care about Earth observation, but also look at all bunch of different space technologies, from quantum to, of course, artificial intelligence, space habitats, and in situ resource utilization, and biotechnology and other technologies. So it's really not only about Earth observation, but very different space technologies. So if you see yourself applying, you can let me know, and yeah, I might help you as well. Yeah.
Is this open to the US?
Oh yeah, it's open for all ESA member states, but it means that the entity needs to be registered in ESA member state, but the person could be from the US. So the entity of the person the entity who is applying needs to be from ESA member state, but then the researchers could be international.
So they can spend the money in the US?
Yes, as long as the entity is registered in Europe, in the member states. Yeah. Also, the program is under ESA basic activities, and it means that all member states contribute to its budget, and it's really low barrier to enter, because other programs at ESA are rather that you need to have national delegates to apply to them. So it's really low barrier to enter, and it's really for everyone. Yeah, like, I really encourage you to apply. So until now, we had around 3,575 ideas submitted. So this is for the open call. but we also launch thematic campaigns about different technologies like swarms of CubeSats, or recently we launched one for large space structures and maintenance in space. So it could be either some thematic campaign or just open call. And also in my team, we use data science and AI to kind of extract information from all of these project proposals and cluster them automatically, for example, or extract what are the trends at the moment in the submitted proposals, or also to figure out what is missing and not yet addressed at ESA that we might want to take a look in the future. So we use data science to kind of provide more insights of the program, either to the higher management or ESA member states and their delegates. This is the Open Discover Ideas channel where you can submit your ideas and your proposals. I'm going to share with you the presentation afterwards, so you will have the QR codes in one place, but this is how does it look like. Yeah, and the process is straightforward. You just submit the proposal to the web page, and then ESA experts evaluate it, and it may result in a contract. And the funding depends on the type of contract that we agree on. So, as I mentioned, this program is for low readiness levels of technologies. And if the technology is a higher readiness level, then it is better to apply to other technology programs at ESA, like GSTP or InCubed for Earth observation, or ARTES for navigation, and the other programs. So if you really want to test a solution, then OZIP and Discover and Preparation is a way to go. Other part of our team, of our work, is preparation of future missions, and we work on preparation of the early phases of space missions. I mean pre-phase A, phase A, and phase B1. And around only in 1 year, we take a look at 30 different missions. We also found the concurrent design facilities, which are special meetings if we want to discuss a mission concept that is not yet proposed to the member states. So a bunch of engineers and different working groups are closed in one room for the entire day, and they discuss different trade-offs of the mission and whether it makes sense to continue with its development. So this year we had the concurrent design facility of AuroraSea mission, that is a swarm of satellites for monitoring of the northern lights. We look at the pre-phase A missions phases and phase A. So for example, Sentinel-2 and Sentinel-3 next generation, we found these kind of studies. Last but not least, we run the Visiting Researcher program, and it enables you to use ESA facilities and exchange knowledge with ESA experts for 1 year. And at the moment we have around 50 researchers in the program, and this is also an open call, so you can register all year round. At the end, I attach the useful links to the web pages that you may explore. So OZIP is the page that you might want to send your proposal, or if you want to view other similar proposals that have been submitted to the program, you can go to Activities portal or the Nebula portal. Thank you for today. If you have any questions, I can take them now or later at the coffee breaks, and I will be here all week. Yeah.
Yeah, just wondering how much of an interest is there for Julia? You know, how many colleagues of yours are using?
Yeah, to be honest, none of my colleagues are using, and yeah. In my team, we use Python at the moment, but I'm trying to maybe like use it for some dashboard preparation. Yeah, but as far as I know, like in my team, there is no people using Julia. Maybe in other directorates, yes, but I'm not aware of.
So I guess it's very useful if we send proposals to you that are emphasizing Julia, and we might have you as a reviewer as part of the case.
Well, then I would need to, like, there will be like a conflict of interest between us, so then I'm excluded from the evaluation.
Oh, I see.
Yeah. Yeah.
I was going to ask, so one of the cool things about DashJL is that it kind of democratizes the ability for someone to build a GUI without needing the knowledge at hand to kind of do it from scratch. And typically, in my workflows, we work with large data. So when using DashJL, do you notice any kind of performance hits when building GUIs for large data sets, or is DashJL usually the kind of sweet spot for its use is more in the smaller data regime?
Well, I didn't use it for a very, very large data set, so I don't know about this hands-on. In my data set, it was just rather fast. I never remember waiting to have any results, but yeah, at the bigger data sets, I'm not sure.
So no more questions, lunchtime?
Yeah.